Difference. We're going to see the next representation for a graph. So this is the adjacency list representation, so which is a dynamic representation. So we consider the same graph here. So here we used an array of linked list. So in order to create this, we have two classes of or two groups of linked lists. So we take care of, so if you divide a graph into a picture like this, we write it at the nodes, all the nodes, and for each node its adjacent nodes, which is called the adjacency list. So for A, if you look the node A, so for node A, the adjacency nodes are B and C. That means they are its neighbors. So A's neighbors are B and C. Similarly, B, if you look, its neighbor is only D. C neighbor is only D. D's neighbor is only E, and E has no node, so it is a null. And so we connect every node to the next node in the list in order. So for example, so we have a pointer that points to the next node, and each node contains also a point to the first node in the adjacency list of that node. For example, A's first is B, then B points to the next, that is C. So we use two groups of linked list structures, self-reflective structures. So this is one which is used to represent a node. So here we have data is a node item, let's say A, integer or character, whatever you want. Then we have a next pointer that this points to the, it's a down pointer. This is the down pointer that points down to the next node on the list. And we have an adjacency pointer which points to the first node in the adjacency list. So there are three items here. If you look, this an element called node. So that is used for this. And the next is another class of nodes which are called adjacency list. We call that an edge, that structure. Then so there will be first a destination item, that is the value of it, for example B, and we have a pointer next. So this is a link pointer that points to the next item in the edges list. So here there is one data item and a pointer. So one item and a pointer. Here there is one item, two pointers. So three elements here and two elements here. So this is one way of representing an adjacency list. So if you look at this representation, just the table itself, we find it is nothing but this is a linked list, an array of linked lists. So a combination of linked lists. So we use a double path linked list. We can create this for a particular given graph, representing it using an adjacency list. So these are the two representations used for a graph: adjacency matrix, which we saw, and adjacency list.